So in the last class, we have discussed about pelletization process, that is the green ball formation, and today we will discuss about induration process. So once the green balls which are formed on the disc pelletizer, these green balls are subjected to screening by using double deck screening system, where we can do the screening operation based upon the roller gap between the two rolls in the double deck screening system, and we can obtain the range of size range of iron ore pellets of 8 to 16. And these green pellets are subjected for the induration process, where this induration process consisting of three-stage process, that is drying, preheating, and firing. So there are currently two different methods by which we do induration process. One is Grate-kiln technology, other one is Straight-grate machine. Before that, we also used to have another method, that is vertical shaft furnace for the induration of green pellets. This is basically was present in KIOC, that is Kudramukh Iron Ore Company Limited, which is located in Mangalore, Karnataka. But slowly this process has abandoned because of the vertical shaft furnace and because of low strength of green pellets, this process has abandoned. But currently we are using the Grate-kiln as well as Straight-grate machine. So we will discuss about first the Grate-kiln technology. So in the name itself, it is clearly mentioned, you have a traveling grate followed by a kiln. So it is a two-stage process. One is a traveling grate, followed by there is a kiln. So on the traveling grate, the drying and preheating will take place, and in the kiln, the firing will take place. So as we discussed that the induration process consisting of three stages: drying, preheating, and firing. So out of these three steps, two steps, that is drying and preheating, will be done on the grate, and firing will be done in the kiln. Yeah, so this is the schematic diagram of the Grate-kiln technology. There you can see this is the traveling grate, and this is the kiln. And this is the double deck screening system, where green pellets are screened between the size range of 8 to 16, and the undersize and oversized pellet, that is pellets of plus 16 mm size and pellets of minus 8 mm size and plus 16 mm size. Yeah. So these sizes, the undersize and oversize, will be written back for the pelletization, and 8 to 16 mm size range pellet will be subjected for the induration process. So here again you have in the drying and preheating also, you have two-stage drying process and two-stage preheating process will be there. The first one is there is UDD, there is updraft drying zone, and there is a DD, there is downdraft drying zone, and you have preheating zone 1 and preheating zone 2. Followed by you have a firing. So here the hematite ores especially, they contains a high amount of SiO2 and Al2O3. So because of these refractory oxides, there is a possibility of accretion formation takes place within the kiln. So Grate-kiln is not feasible for hematite ores, but still people are adopting this kind of method for the induration process, hematite ores. As if you see, the magnetite ores are basically having a spike morphology, and they're also very hard. So because of that, there is a possibility of wear out of the kiln refractory may take place. But this wear out phenomena is very nominal. So that's why, especially wherever we are using magnetite kind of ores for the preparation of the pellet, there especially we use the Grate-kiln technology. In India, if you see Jindal SAW, which is in Bhilwara district, Rajasthan, so there they are doing this pelletization process using magnetite ores and their facility of Grate-kiln technology. Yeah, so this is a schematic view of Grate-kiln process, where you can see, as I told you just now, that you have two drying zones and two preheating zones, and this is the kiln you have, and this is the annular cooling zone. So you have drying, preheating, firing, and then cooling. Yeah. So now we will see the dimensions of this Grate-kiln arrangement. The traveling grate, whatever we have seen here, this is the traveling grate. This entire the length and width of this entire traveling grate, if you see, it will be of around the width is of around 4 meters approximately, and length is of approximately 42 meters. And similarly, the dimensions of the kiln, you see the diameter and the length of the kiln. The diameter is roughly around 5 meters and the length is of around approximately 35 meters. And also we have, as I shown you, we have an the cooling annular cooling zone. So this also we have the dia is around approximately 12.5 meters and the area cooling area is around approximately 69 meters square. And on this grate, traveling grate, we arrange the pellets in the form of a bed of height approximately 180 to 200 mm, and the production rate of this machine is around 1.9. Production speed is of around 1.9 meters per minute. And this grate is again divided into 4 zones. That is the updraft drying zone, downdraft drying zone, then preheating zone 1, preheating zone 2. So this total 42 meter length, whatever it is there, that is divided into these 4 parts. 6 meters of updraft drying zone, then 12 meters of downdraft, then 9 meters of preheating zone 1 and 15 meters of preheating zone 2. So this is how it is. The total, if you sum up, it will be around 42. We'll see what is happening in the updraft drying zone and from where that heat is coming, the amount of heat which is required for the drying of the pellets. So from where we are receiving that heat, that we'll discuss now. So I just whatever I have discussed here, this particular part I have just taken the kiln, the grate part, and I just extrapolate here. So you can see, so this one is the updraft drying zone, this particular chamber, where the heat is supplied to this particular chamber from cooling zone 3. So here you can see the annular cooling zone here. You have zone 1, zone 2, and zone 3. So in this particular picture, you can clearly see zone 3 means here. That means around the temperature is 263 degrees centigrade. That means during the cooling process, whatever the heat we are trying to extract from the pellets, that heat is supplied for the drying process. So you can clearly see this thing in this particular picture. You can just follow this particular pipe. So it is moving towards the first compartment. So here you can see, as I told you, it is basically the updraft drying zone. Updraft means we are supplying the heat from the down and doing the suction from the top. So that is what happening here. That is the updraft. The draft is moving upwards, and we are supplying that from the bottom. So that why we are doing first updraft, thus pellets, whatever are at the bottommost layer, as I told you, that we are making a bed of height around 180 to 200 mm that we are making. Right? So the lowermost layer of the pellets has to bear the entire load, is above it. So first, if you dry the bottommost layer of the pellets, then these pellets will attain good strength and it can bear the rest of the layers. You can bear the weight of the rest of the layers. So that's why first we are trying to dry the bottommost layers of the pellets. That's why we are providing heat from the bottom, so that first the bottommost layers will get first dry, so that they can attain required strength and they can withstand the load above it. So in this particular picture, you can see from the bottom we are actually giving, and from the top we are doing the suction. Okay, so actually this pipe, whatever it is there, it is actually from the back side, it is gone and it is entered from the bottom. And you can see from the top we are doing the suction. So this is nothing but the updraft drying zone. And you can also see what is the temperatures. The input temperature is around 260 degrees centigrade. That is what the temperature we are giving from the bottom, and this heat is coming from the cooling zone 3. And when the heat is traveled through the bed of solids, certain amount of heat is transferred from the gas to the solid. So there is a heat transfer which is taking place. So because of which certain amount of heat loss may take place. So the final gases which are coming out from the top, you see that will be having a temperature of around 100 to 105 degrees centigrade. And even in fact, you can see in this particular picture, it is around 93 something, this one 93 degrees centigrade. So this is the updraft drying. Then next one is now once we have given updraft, now this time we'll give the downdraft. Now in the downdraft, what is happening? The heat is coming in contact with the top layers of the bed. At the initial stage, bottom layers will get dried off, and now in the downdraft drying zone, the top layers will expose to the high temperatures, and and the top layers also will get will get dried. So the amount of heat which is necessary for downdraft, that is basically coming from the preheating zone 2. You can see that here clearly. Just follow this line. This is the preheating zone. You see, this is the draft, this is the downdraft, this is preheating zone 1, this is preheating zone 2. From the preheating zone 2, so this is the from the top, I'm doing the suction. See this pipe, just simply follow this pipe. Yeah. So here I am just giving the input, the heat. I'm giving heat. Okay. So this is called the downdraft. So from the top, I am giving the heat. So the heat, whatever heat I am supplying, that will be first exposed to the top layers of the pellet bed. So the input heat will be, that is of around 325 degrees centigrade. It comes from the preheating zone 2 and enters into the drying zone from the top, and the outgoing air will be around 280. So you can clearly see in this particular slide also, the input is around 331 degrees centigrade is what it is showing here, and output temperature is around 278, it is showing here. Okay, so this is how the drying is taken place in the movable bed. Next, coming to the preheating zone 1. So here, once the drying is done, then we are doing the preheating. So in the drying zone, what happens is that the maximum amount of moisture which is present inside a pellet will be completely removed. And in the preheating zone 1, here the input temperature will be of around 900 degrees centigrade. That we are, again, you can see here that we are supplying from the cooling zone 2. You can clearly see again this particular pipe having a temperature of around 900 degrees centigrade. If you just simply follow this particular pipe, you can understand that where this pipe is going. Yeah. Okay. So this is the cooling zone 2, and from here we are recovering the heat, and that heat is supplying to the heating zone 1. So whatever the heat we are recovering at the annular cooling zone, that heat is supplying to the preheating zone. Same thing I have discussed when I mentioned about the annealing hood also. There also, once the sinter has come out from the combustion, sinter bed has come out from the combustion zone, immediately there is an annealing hood is there. So there also we supply the heat which is recovered from the annular cooling zone. That is in the sintering process. Similarly, here also in the pelletization process also, heat whatever it is recovering during the cooling process, that heat is supplying for the drying and preheating process. So the input heat you can see here, it is the 900 degrees centigrade, but during its travel from here to here, there is a certain drop in the temperature may take place. Okay. So the input temperature is approximately around 900 degrees centigrade. This is what we are supplying. We are extracting from the cooling zone, in fact, and there is a drop during its travel, and the final input temperature is approximately 660 degrees centigrade. This will enter into the preheating zone 1 from the top of the bed, and it travels through the entire bed and comes out at a temperature of 330 degrees centigrade. So there is almost 300 degrees heat is supplied to the bed of solids. Then followed by you have preheating zone 2 is there, where as this, if you see in this particular picture, this preheating zone 2 is residing next to the kiln, the inlet of the kiln. So here the temperature, whatever you have in this particular picture, also you can see around the temperature around 1040 something like that. So directly this heat is supplied to the heating zone 2. From the kiln itself directly. So the preheating zone is next to the rotary kiln, so the required heat that is around approximately 1000 degrees for the zone 2 is supplied from the rotary kiln itself, and the outgoing bottom air temperature will be around 295 to 340 degrees centigrade, and as you can see that that heat, whatever it is coming out from the preheating zone 2 is simply, you can see here also it is coming out, and you can clearly see in this particular picture also the temperature around 340 is showing. So it is traveling, and it is entering into the your uh, drying zone. Okay. So here in the preheating zone 2, what is happening is within the bed there is a possibility of liquefaction and a solid bond formation may take place. And whatever the waste heat which is coming out from this entire grate, whether it is updraft or downdraft or preheating zone 1 or preheating zone 2, whatever it may be, these all will finally connected to the electrostatic precipitator, where the waste heat as well as the dust is separated, and the waste gas is sent to the out to the chimney. Now, once the drying and preheating is done, the next thing is the firing. So, as far as the firing is concerned, then this will be usually done in the rotary kiln. If you see the specifications of this, the length of the kiln is around approximately 35 meters, and the dia is around 5 meters, and it is inclined at an angle of 0.4 degrees. And inside this kiln, it is a refractory lined system, where 250 mm thick aluminum refractories are used for lining purpose. And this kiln is rotated at an RPM of approximately 1. And you have the burner is arranged here at the outlet end of the kiln, which is ignited using furnace oil. And around certain amount of PCI is also charged into the kiln. You can see in this particular picture around 3.4 it is showing. That is around 3.4 tons of PCI is injected into the kiln per hour. The temperature at the charging and discharging end of the kiln will be approximately 1000 to 1100 degrees centigrade. But you can clearly see here also. Here also the temperatures. Here also you can see the temperatures. And then followed by you have annular cooling zone is there, where it consists of 3 zones. This annular cooling system is divided into 3 different zones. And this annular cooling zone rotates at a speed of 0.8 meter per minute. And the pellets which comes out from the cooling zone 3 will be having the lowest temperature. There is a final cooling zone. It's having a temperature of around approximately 100 degrees centigrade, and these pellets are transported to the stockyard through the conveyor belt. So this is all about the Grate-kiln technology. The next one is the Straight-grate machine, where again you don't have any kiln, but you have entirely Straight-grate is there. Where here also you can see this is the two chambers, that is updraft UDD is the updraft drying zone, this is a downdraft drying zone, then preheating zone, then you have firing zone, then you have after firing zone, then cooling zone 1, cooling zone 2, followed by you have a conveyor belt and they have a screening system, and then after screening you'll be subjected for the required size, whatever is sufficient for charging the pellet pellets into the blast furnace, that size, and the undersize or oversize, whatever it is there, that is again sent for the half layer. Here, if you see, this is in our group organization, that is the Verbal. So the length of this entire machine is of around approximately 116 meters, and total pellet cars are around 117. The grate bars moves at a speed of approximately 2.5 meter per minute, and the hearth layer is around 60 mm. Again, you see here, as I told you in the sintering process also, we maintain some hearth layer so that protect the grate bars present on the pellet. Here also we provide a hearth layer of around 60 mm height, and the total bed height is around approximately 400 to 460 mm. This is the procedure where we do the induration process on the straight-grate machine. So as just now we discussed how the heat is supplying from one stage to other stage in the Grate-kiln technology. Here also in the straight-grate machine also, you can clearly see in this particular picture also the amount of heat which is required for the updraft drying zone. The updraft drying zone that is supplied from the cooling zone 2. So you can, these arrow marks are clearly showing from where we are recovering the heat. So we are recovering the heat from here, and that heat is supplied to the updraft drying zone. So updraft means from the bottom we are supplying, and the draft is traveling up, so that the bottommost layers of the pellet will get dry first. So this is updraft drying zone. Similarly, in the downdraft drying, for downdraft drying zone, the amount of heat whatever it is required, that is supplied from the preheating zone. So you can see the specifications here. The updraft drying zone, its length is around 12 meters, and these 12 meters are divided 6 wind boxes at the bottom. Means for every 2 meters you have one wind box approximately, and the input temperature is around 280 degrees centigrade. That is what we are giving. Means the amount of heat we have recovered from the cooling zone 2. You can see here the cooling zone 2, that heat is supplying. So this is around having a temperature around 280 degrees centigrade, and out temperature is around 110 degrees centigrade. So approximately around 170 degrees temperature is absorbed by the bed of solids, and the residence time of because it's a traveling grate. So in this particular zone, the updraft drying zone, the pellets will reside for approximately 5 minutes. And then you have, so here also the same thing I have shown you, from the cooling zone 2, we are getting the heat. Similarly, you have a downdraft drying zone where we are getting heat from the preheating zone. You can this red arrow marks will represent the heat supply. From the preheating zone, we are getting the heat to the downdraft drying zone. So here again, the length of the downdraft is around 16 meters. Again, we have 8 wind boxes. As I said, that every 2 meters, 1 wind box, and that the temperature whatever we are supplying is around 230 degrees centigrade, and the temperature which is coming out from this particular chamber is around 100 degrees centigrade. Residence time of the pellets inside this particular chamber is around 6.5 minutes. And you have heating zone. Again, this preheating zone is further divided into 4 zones: zone 1, zone 2, zone 3, zone 4. And in zone 1, you have temperature of around 250 to 260. Then zone 2, 350 to 380. And then 550 to 580. And zone 4, 680 to 840. Okay, this is the temperature which is residing in this particular preheating chamber. And the total length of this particular preheating zone is around 18 meters, and the residence time of the pellets inside this particular chamber is around 7 minutes, and the outgoing temperature is around 100 degrees centigrade. And then you have firing and after firing zone, where its length is around 34 meters. We have again 17 wind boxes are there. The input temperature is around 950 to 1335 degrees centigrade, and output temperature is around 280 degrees centigrade. So here in the firing and after firing zone, we have burners are there. So you can see its total length is 34 meters, and you have 34 burners are there. So means that every 1 meter you have a one burner is there across its length, and we use furnace oil and air for this combustion process. And the residence time of this particular the pellets inside this particular chamber is around 14 minutes. And then you have cooling zone 1, where its length is around 22 meters. Again, 11 wind boxes are there. So here we are doing the section of air from the ambient atmosphere. So we are supplying air from the ambient atmosphere, and the air is coming out. The heat is coming out from the cooling zone 1 is around 1020 degrees centigrade. That means a huge amount of heat which is recovered from the pellets, and that heat is supplied to the firing and after firing zone. And here the residence time of the pellets in this particular zone is around 9 minutes. Then you have cooling zone 2, where again this length is around 14 meters, 7 wind boxes. Here also we are doing the suction of the air from the ambient atmosphere, and the air is the heat which is coming, which is recovered from the pellets is around 300 degrees centigrade. And residence time of pellets in this particular chamber is around approximately 6 minutes. And this heat 300, whatever we have recovered, that is supplied to the updraft drying zone. So this is how we are doing drying, preheating, firing, and then cooling of the pellets. And this is how we are supplying the heat within the straight-grate machine. So I'll stop it here, and in the next class we will discuss about what actually happens during the induration process. What kind of changes which we can observe in the bed of solids during the induration process. So that we will discuss in the next class.